Hello, ninth class students. The next chapter which I am going to start for you is atoms and molecules. See, when it comes to SSC examination, this chapter is very important, because in the next year you have a chapter by name structure of an atom, which is again a high weightage chapter, and when it comes to intermediate, again this chapter repeats. Okay, so the foundation which you will be receiving in the ninth class is going to help you understand the chapters in the later stages or the advancement of the topics in atoms and molecules. Okay, so I'm going to start atoms and molecules. It's a bit lengthy chapter and I'll be going in very detail for this one, so watch the videos which I'm giving you now.
Hello friends, this video on atom and molecules part 13 is brought to you by examfear.com. No more fear from exam. Let's take some examples to practice. So we have to find the number of moles of the following: 52 gram of helium. See, you have to find the number of moles. So 1 mole of helium is how many grams? Is the molar mass of helium? That is 4 gram. So 4 gram is 1 mole. 4 gram of helium is 1 mole, then 52 gram of helium is how many mole? So 52 gram of helium will be how many mole? So let's do the math. 4 gram of helium is 1 mole. So 52 gram of helium will be how many moles? 1 by 4 into 52 mole. You solve this, you get 13. So 52 gram of helium is nothing but 13 moles. And 13 moles is 13 into 6.023 into 10 to the power 23 atoms. Because we're talking about the helium atoms. Okay. The next is these many number of helium atoms. Find the moles from number of particles. So we know that 6.023 into 10 to the power 23 atoms of any substance, let's take helium here, is equal to 1 mole. So if these is equal to 1 mole, these many number is equal to how many mole? Let's see that. Equal to 1 by the old value multiplied by new value. You solve this, you get 2 mole. So these many particles is nothing but 2 mole of helium. Okay. Let's take some more. So we have to find the mass of 0.52 mole of nitrogen gas, 0.5 mole of nitrogen atom, and these many numbers of atoms. So you have to find mass. Please note, in all these cases you have to find the mass. Okay. So mole is given, you have to find the mass. We know that 1 mole of element weigh molar mass in gram of that element. That means 1 mole of nitrogen gas will be how much? Nitrogen is 14 into 2, 28 grams. That is 1 mole of N2 gas. So if 1 mole of N2 gas is 28 gram, 0.5 mole of N2 gas will be how much? 28 by 1 into 0.5, that is 14 gram. Done deal. The second is 0.5 mole of N atoms. Please note, this was molecules, this is atom. So again, 1 mole of N atoms will be how many grams? 14 grams. But the molecular mass of N atom will be 14. Molecular mass of N2 will be 28 because there are 2 N here. So 0.5 mole of N will be 14 by 1 into 0.5, that is 7 gram. Please note that N atoms and N2 gas both are different. Then third is this many number of atoms. So we know that 1 mole of element with this many, we know that, but 1 mole is nothing but 6.023 into 10 to the power 23 particles. These many particles will be 1 mole and that will be molecular mass. So we know that 6.023 into 10 to the power 23 N atoms is equal to 1 mole of N atom, and that is equal to 14 grams, right? So let's ignore this one part now. So we'll have atoms, particles and the weight in one equation now, and that's what we have to find. These many atoms is 14 grams, so these many atoms is how many grams? So these many atoms will be how many? 14 by this value 6.023 into 10 to the power 23 into this value. You solve this, you get 7 gram, and that is the answer. Pretty easy. Let's take some more example. Here we have to find the number of particles. In the last example, we found the mass of the whole sample. Here we have to find the number of particles in a given sample. Here the mass of the gram is given, mass of this is given, mole is given. So we know that 1 mole is 6.023 into 10 to the power 23 particles. For any ion, molecules, atom, doesn't matter. Golden rule. And 1 mole is nothing but molecular mass in gram, if you want to find the weight. So the first thing given is 46 gram of sodium atoms. First, let's find the number of moles in these. We know that 23 grams of sodium atom is equal to 1 mole. Right? The molecular mass of sodium is nothing but 1 mole. So with this, 46 grams of sodium will be how many moles? Obviously 2 moles. Correct? You can do maths. So 2 mole is what? 2 into these many particles. That is 2 into 6.023 into 10 to the power 23 particles. You can do the maths. It will be 1.2044 into 10 to the power 22 particles, or 12.044 into 10 to the power 23 particles. You can do that maths. First part is done. Second part, similar, 8 gram of oxygen. So we know that oxygen 16 into 32 gram of oxygen molecule implies 1 mole. So 8 grams of oxygen molecule will imply 1 by 32 into 8. These many moles, 1 by 4 moles. And 1 by 4 moles is nothing but 1 by 4 into 6.023 into 10 to the power 23 particles. This is molecules, so I can write molecules only directly. You solve this, you get 1.51 into 10 to the power 23 molecules. You can write particles, general word, or you can use molecules. Here it was atom, so I can write atom as well. Done. Third is pretty simple, 0.1 mole of carbon atoms. So we know that 1 mole of anything is nothing but 6.023 into 10 to the power 23 particles. Here we talk about atoms. So 1 mole of carbon atoms will be this many atoms. So 0.1 mole will be what? 0.1 mole of C atoms. It will be 0.1 into this value. About 23 atoms. And that is nothing but 6.023 into 10 to the power 22 atoms. Okay. The question is 1 mole of carbon atom weighs 12 gram. We have to find the mass of 1 carbon atom. So we know that 1 mole of carbon atom is what? 6.023 into 10 to the power 23 atoms. And this weigh 12 gram. So mass of 1 atom will be how much? 12 by 6.023 into 10 to the power 23 gram. Solve this, you get 2 into 10 to the power minus 23, almost approx. So that is the mass of 1 carbon atom. Okay. The question is which has more number of atoms? You take 100 grams of sodium in place, 100 grams of iron in one place, and the atomic mass is given. So to find the more number of atoms, we can just find which has higher number of moles, because number of atoms is directly proportional to mole. We have seen that 6.023 into 10 to the power 23 atoms is 1 mole. So let's find the moles in both cases. So for sodium, 23 is the atomic mass, so 23 gram of sodium is 1 mole of sodium. So 100 gram of sodium is what? Is 1 by 23 into 100 mole of sodium. Approximately 4 mole of sodium. Let's find the moles of iron. Iron is 56. 56 gram of iron implies 1 mole of iron. So 100 gram of iron will imply 1 by 56 into 100 mole of iron, and that is almost equal to 2 mole of iron. This is 4 mole, this is 2 mole. This is 4 mole, that means it is 4 into 6.023 into 10 to the power 23 atoms. This is 4 mole, that means it is 2 into 6.023 into 10 to the power 23 atoms. So which one is more? Obviously iron is more, because this is 4, this is 2. So sodium has more atoms. Sodium is more. Right? It has more atoms. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on atom and molecules part 14 is brought to you by examfear.com. No more fear from exam. Let's do a recap of what we have done, and after that we'll do some numericals. We have seen that during a chemical reaction, sum of the mass of reactant and the product remains same. Right? We have seen that carbon plus oxide is equal to carbon dioxide, and we have seen this in this, let's suppose 12 gram of carbon and 32 gram of oxygen was used, so we got some 44 gram of carbon dioxide. Right? All the reaction happened. So the mass of reactant and mass of product is always same, right? This is law of conservation of mass. The second thing we studied is in the pure chemical compound, elements are always in the definite proportion. For example, you take water from any source, you take water from well, ocean, river, doesn't matter. You'll always have 2 molecules of hydrogen and 1 molecules of oxygen combined to form water. This is called law of definite proportion. Atom is the smallest particle of the element that exists independently and retain all its chemical property. Very few, but mostly it is in the form of molecule. For example, you will see oxygen molecule, right? But Some case atom also exists independently, for example helium. Okay, molecule is the smallest particle of element that is capable of existing independently under all conditions, and it shows all the chemical property. Right? Please note there is a can here, and this is under all conditions. That's why I told oxygen can exist, but oxygen typically exists in O2 or O3 form. This is molecule form, right? And these shows all the property, and this retains all the property here. So you can actually break a molecule to atom, and that will exist independently under some condition, but this is molecule exists under ordinary condition. Okay. We talk about the chemical formula. It shows its constituents elements and the number of atoms of each combining element. For example, water molecular formula is H2O. It says that there is 2 hydrogen and 1 oxygen combined. And we have also studied the rules to write chemical formula. Cluster of atoms that act as ions are called polyatomic ions, and they have charge. Example, SO4 2 minus, NO3 minus, right? CO3 2 minus. These are all polyatomic ions. And the chemical formula of a molecular component determine the valency. We have by valency we have seen that. For example, HCl plus 1 minus 1, you do a swap, you get HCl. Water, H and O plus 1 minus 2, you do a swap, you get H2O. This is something we have seen. Ionic compound, the charge on each ion is used to determine the chemical formula. So for other thing we use, for covalent we use actually the valency, for ionic we use typically charge. And scientists use relative atomic mass to scale actually to compare the atomic mass of different elements. And carbon 12 isotope is assigned the benchmark, and every other element relative atomic mass is considered or is calculated or is calibrated using mass of carbon 12 isotope. Right? In the history we have seen earlier hydrogen was used, then oxygen, and then carbon 12. Avogadro constant, this is 6.22 into 10 to the power 23. This is the number of atoms in exactly 12 grams of carbon 12. Okay, and the mole of a substance is nothing but any thing which has exactly 6.023 into 10 to the power 23 particles, or it is nothing but the molecular mass amount of that particular substance. So as I told, the mole is the amount of substance that contains the same number of particles, and the particles can be atoms, ions, molecules, etc. That is there exactly in 12 gram of C12, and there is nothing but this number. Also we told mass of 1 mole of substance is nothing but its molar mass. Okay, let's take some numerical now. 0.24 gram sample of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Find the percentage composition by its weight. So I have a sample which has oxygen and boron. So oxygen and boron. Okay. It contains 0.096 gram of boron. 0.096 gram of boron and 0.144 gram of oxygen. Let's add these two values. So when you add this, you get 0.42, and that is the total sample. Correct. Okay. So we have a sample 0.24 gram which has 0.144 gram of oxygen and 0.96 gram boron. We have to find the percentage composition of compound by weight. The percentage of boron will be what? Mass percentage will be what? Mass of boron by mass of sample. into 100. Put the value mass of boron is 0.96, sorry 0.096 by 0.24. This is gram, this is gram, and this is 100. Gram gets cancelled. You solve this, you get 40%. Similarly, mass percentage of oxygen, you can actually say that this is mass of oxygen by mass of sample into 100. Directly you can say that is mass of oxygen is 0.44 by 0.24 gram into 100. You solve it, you get 60%. Or directly you can say that mass percentage of oxygen is 100 minus 40%. That is also one way, because there are only two compounds in this. To be on safe side, always calculate. Okay? Because let's suppose it has some X other compound that had some weight and total weight was not 0.24, then direct formula won't work. So better you calculate for all in the exam. The next question is, when 3 gram of carbon is burned in 8 gram of oxygen, 100 gram of carbon dioxide is produced. What is the mass of carbon dioxide formed when 3 gram of carbon is burned in 50 gram of oxygen? Carbon is burned in oxygen to form carbon dioxide. T is equal to 0. This was 3 gram. This is 8 gram. And this was 0 gram. T is equal to T. Some 11 gram of carbon dioxide is produced. Law of conservation of mass. That means all these gram is used, right? This becomes 0 and this becomes 8 plus 3, 11. 8 plus 3, 11. So 11 and this is 11. Perfectly fine. Okay. Now, again, this is one scenario. The second scenario is 3 gram of carbon. This is 3 gram. 50 gram of oxygen. 50 gram. And this is 0. So at T is equal to T, what will happen? See, 3 gram of oxygen will only react at the max with 8 gram of, 3 gram of carbon will react at the max with 8 gram of oxygen, nothing more than that, right? This is because in this case, both reactant and produce are, both the reactants are consumed, right? Carbon and oxygen is consumed to give 11 gram of carbon dioxide. So that means this will become 0 and this will become 50 minus 8. Only 8 gram will be used, and here you get 11 grams again. So question is, what is the mass of carbon dioxide produced? So here also 11 gram of carbon dioxide will be produced. Only 8 gram will be used. And here also law of conservation of mass, if you see, at T is equal to 0 we had 53 grams, and T is equal to T will have 42 plus 7, 53 grams. But note that if you provide excess oxygen, all the oxygen will not be used, it will be unused. Right? So that means when you burn a matchstick, all the oxygen on the earth doesn't get vanished. Only the oxygen required to burn that matchstick is used. Other oxygen, remaining oxygen is still in air. Here also in second scenario, what we are doing is we are pumping in more oxygen. But to burn 3 grams, only 8 grams of oxygen is required. To burn 3 grams of carbon, only 8 grams of oxygen is required. So only 8 grams of oxygen will be used and the remaining will be unused. Okay. And actually you can prove this typically because law of conservation by mole also, 1 mole of carbon reacts with 1 mole of oxygen molecule to give 1 mole of carbon dioxide. 1 mole is 12 gram. This is 32 gram. Right? So 12 gram reacts with 32 gram, or divide each of by 4. What you get? 3 grams react with 8 gram, and that's what we have seen. Right? Because the common number we can divide. 3 grams of carbon will react with 8 gram of oxygen. So even if these numbers are not known, even if these numbers are not given, directly if you have this question that 3 grams of oxygen reacts with 50 grams of 3 grams of carbon reacts with 50 grams of oxygen, how much carbon dioxide is produced, you should actually be able to find out using the concept of mole. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on atom and molecules part 15 is brought to you by examfear.com. No more fear from exam. What are polyatomic ions? Give some example. See, polyatomic ions are clusters, groups of atoms that always have some fixed charge attached to them. These charges can be positive or negative. For example, ammonium ion, OH minus ion, NO3 minus ion, CO3 2 minus ion, SO4 2 minus ion. These are the common ions, polyatomic ions. They are the clusters of the groups of atoms with a fixed charge. Charge can be positive or negative. We have to write the chemical formula for these compounds. Magnesium chloride. I have magnesium metal, chlorine non-metal, +2 charge, -1 charge. Let's do a swap for charge balance. This becomes MgCl2. Okay. The next is what? The next is calcium oxide. So let's put that. So we have calcium, we have oxygen, +2 charge, -2 charge. Let's balance it. This becomes 2, this becomes 2, 2, 2 common, we get CaO. The next is copper nitride. Copper is a metal, NO3 is a non-metal, +2 charge, -1 charge. Polyatomic ions, so I put in braces now. So this becomes 1, this becomes 2. This becomes CuNO3 2. Aluminium chloride AlCl +3 -1. Swap it. This becomes AlCl3. Calcium carbonate. This is calcium. This is carbonate. +2 -2. This becomes calcium carbonate. Okay. So we have to give the names of the elements present in the compound. Quicklime. Quicklime is calcium oxide. Hydrogen bromide is HBr. Baking powder, remember this baking powder, this is NaHCO3. Potassium sulfate, K2SO4. So we have to find the molar mass of these compounds. C2H2, 2 carbon, 2 hydrogen. 2 carbon is 2 into 12, 2 hydrogen is 2 into 1, that is 26 gram. Sulfur 8S8, so 8 into 32, that is 256 gram. Phosphorus P4, each phosphorus is 31, 31 into 4, 124 gram. HCl, 1 hydrogen, 1 chlorine, 35.5. You add them, you get 36.5 gram. Nitric acid, 1 hydrogen, 1 nitrogen, 14, 3 oxygen, 3 into 16. You solve it, you get 63 gram. So here again we have to find the mass of these compounds. The first is the mass of 1 mole of nitrogen. See, 1 mole of nitrogen is nothing but the molecular mass, and it is atom, so it is nitrogen atom, that is N, so that will be 14 gram. That's all. Second is 4 moles of aluminium atom, so each mole is 7 grams, so 4 will be 4 into 27, that is 108 grams, because it's aluminium atom. Third is 10 mole of sodium sulfide. 1 mole of sodium sulfide will be how much? 2 sodiums, it's 2 into 23. 1 sulfur, sulfur is 32. 3 oxygen, 16 into 3, this many grams, right? That is 126 grams. So 1 mole of Na2SO4, Na2SO3 actually is 126 gram. So 10 moles of Na2SO3 will be 10 into 126 gram, that is 12605. Okay. Again, here you have to convert to mole. 12 gram of oxygen. So 12 gram of oxygen is what? Oxygen gas. Oxygen gas is O2. Please note, this is not oxygen atom. This is O2, oxygen gas. So we know that, but 23 gram of O2 gas is 1 mole. So 12 gram of O2 gas will be how many? 1 by 32 into 12. That is 0.375 mole of oxygen gas. Done. 220 gram of water. We know that water is H2O. 16 plus 2, 18. 18 gram of water is equal to 1 mole of water. So 20 gram of water will be how much? Very simple. 1 by 18 into 20 mole. And you solve this, this is 1.11 mole. Next is 22 gram of carbon dioxide. Carbon dioxide molecular mass, if you see, carbon is 12 plus 16 into 32, that is 44 gram. That means 44 gram of carbon dioxide is 1 mole of carbon dioxide. So if 44 gram of carbon dioxide is 1 mole of carbon dioxide, then 22 gram of carbon dioxide will be 1 by 44 into 22 mole of carbon dioxide. And this will be 0.5 mole of carbon dioxide. It is easy. Here you have to find the mass. Mass of 0.2 mole of oxygen atoms. Oxygen atoms is O2. So we know that 1 mole of oxygen atom is 16. Sorry, oxygen atom is O, not oxygen gas. 16 gram. Right? So 0.2 mole of O atom will be 0.2 into 16 is equal to 3.2 gram. Please note, this oxygen atom is not oxygen gas. If it is oxygen gas, we will take O2. 0.5 moles of water molecule is H2O. We know that 1 mole of water molecule is 2 plus 16, that is 18 gram. So 0.5 mole of water molecule will be 0.5 into 18, that is 9 gram. Okay. The next question is calculate the number of molecules of sulfur present in 16 gram of solid sulfur. Number of molecules. See, 6.023 into 10 to the power 23 molecules in 1 mole. And that is nothing but 8 into 32 grams. That is 256 grams. So we know that 256 gram of sulfur molecule will have 6.023 into 10 to the power 23 molecules of sulfur. I want 16 grams. 16 grams of S8 will have 6.023 into 23 into 16 by 256 molecules. You solve this, you got 3.76 into 10 to the power 22. These many molecules will be there in 16 grams of solid sulfur. Let's take the last question. We define the number of aluminum ions present in 0.51 grams of aluminum oxide. So let's see aluminum oxide, Al2O3. You break this into ions, you get 2 aluminum, 3 plus, 3 oxygen, 2 ions. Okay. So aluminum oxide, 1 mole of Al2O3 gives actually 2 moles of aluminum ions, right? Correct. This is something we know from this equation. So we can find the moles of Al2O3 in this gram of aluminum oxide, because here the grams of aluminum oxide is given. We can find the moles of aluminum ions. If we have the moles of aluminum ion, we can easily find the number of aluminum ions. So Al2O3, the molecular mass of Al2O3 is what? Aluminum is 2 aluminum, 2 into 27, 3 oxygen, 3 into 16, 48 plus 54, 102 grams. So that means 102 grams of Al2O3 is equal to 1 mole of Al2O3. And we are talking about 0.051 gram of Al2O3. So that means we are 1 by 102.51 mole of Al2O3. So you solve this, what you get? You get this by 1000 if you remove this dot, and this is 2. So 1 by 2000 moles of Al2O3, right? So these moles of Al2O3 is nothing but twice of these moles of aluminum ion. That is from this equation 1 mole of Al3 plus ion. This gets cancelled. That means it is nothing but 1 by 1000 mole of Al3 plus ion. But what we have to find? We have to find the number of actually ions. So 1 mole of Al3 plus ion is nothing but 6.023 10 to the power 23 ion. So these many moles of Al3 plus will be this many moles into a magical number. So you solve it here is equal to magical number 6.023 into 10 to the power 23 ion. And that is nothing but 6.023 into 10 to the power 20 ions. And that is the. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.